Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the functional groups in the starting material. The starting material is 2-bromomethyl benzonitrile, which contains I, a nitrile group, CN, directly attached to the aromatic ring, and 2, a benzylic bromide, CH2Br, on the ortho position. Moving on to the next step. Reactivity of the benzylic bromide with NaOH H2O. The CH2Br group is a benzylic halide and undergoes SN2 hydrolysis readily with aqueous NaOH to give CH2O, benzyl alcohol. This is a straightforward nucleophilic substitution, CH2Br plus of CH2 of plus Br. Moving on to the next step. Reactivity of the nitrile group with NaOH, excess, H2O heat, and aryl nitrile ARCN undergoes base-catalyzed hydrolysis under aqueous NaOH with heat. The nitrile is first hydrolyzed to an amide, then further to a carboxylate salt, and upon workup gives a carboxylic acid, CHO. With excess NaOH and heat, the hydrolysis goes all the way to the carboxylic acid as its sodium salt, which on acidification gives CHO. And for the final step, both reactions occur, CN2 and CH2Br-CH2O. This gives 2-hydroxymethyl benzoic acid, i.e., a benzene ring bearing CHO at C1 and CH2O at C2. This corresponds to option C. Option A. Only the CN is hydrolyzed, but CH2Br remains unreacted, incorrect because benzylic bromides are more reactive toward SN2 with NaOH than nitriles, and under excess NaOH both would react. Option B. Only the CH2Br is hydrolyzed to CH2O but CN remains intact, incorrect because excess NaOH with heat is sufficient to hydrolyze the nitrile to CHO. Option D shows an additional O on the ring, which is not justified by the reaction conditions. Aromatic rings do not undergo hydroxylation under these conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.